Is coming to the S block elements. S block means the differentiating electron enters into S orbital. Because S orbital contains 2 electrons, it contains 2 groups. The first A group elements, that's NS1. Second A group elements, alkali metals. The configuration is NS2. Totally, the S block contains the electronic configuration, general electronic configuration of S block is NS1 to 2. So, here in one group, first group elements, the electronic configuration is NS1 antunnam. Daniki example sodium. The outermost electronic configuration is 3s1. Similarly, potassium 4s1, 5s1, 6s1, 7s1. So these are S block electronic configuration, S block. And then coming to P block starts with 13 group. Because P orbital contains how many electrons? 6 electrons. P block elements. P block elements. The differentiating electron enters into P orbital. So S block elements ki differentiating electron enters into S orbital. P block means the differentiating electron, the valency electron, the outermost electron enters into P orbital. So in all these P block means it is placed at the right side of the periodic table. Because P orbital contains 6 electrons, totally 3 orbitals. Each orbital contains 2 electrons, means totally 6 electrons. Hence 6 groups are present in P block. 6 groups. P block contains 6 groups. What are those 6 groups? Means the P block placed at the right side. This is P block from 13th group to 18th group. 13, 14, 15, 16, 17, 18. These are 6 groups that are P block elements. So 13 group, 14, 15, 16, 17, 18. 6 groups. 13 group elements. 13 group elements are called boron family. Boron family. The electronic configuration. Chundi S orbital to NS2 complete అయిపోయింది. Then S orbital complete అయిపోయింది. Then the electron enters into P orbital. That means the configuration starts NS2 NP1. That means in 13th group, all these elements, the group elements possess the similar outermost electronic configuration NS2 NP1. All these elements possess 3 electrons in the valency. 1s2, 2s2, 2p1, 3s2, 3p1, 4s2, 4p1 like that. The general configuration is NS2 NP1. Similarly, 14th group means NS2 NP2. 15th means NS2 NP3. 16 means NS2 NP4. 17 NS2 NP5. NS2 NP6. NS2 NP6 means P orbital contains 6 electrons. 6 electrons. That means P orbital completely filled. Hence the P block ends. That means the 13th group lo P orbital 1 to start ayindi. Chudandi P1, P2, P3, P4, P5, P6. That means NP 1 to 6. What about NS? NS is completely filled. So the P block elements, the general configuration is NS2 NP 1 to 6. N s orbital completely filled, s orbital completely filled, and the electron enters into p orbital. So first p starts p1, p2, p3, p4, p5, p6. ns2, np 1 to 6. This is the electronic configuration of p block. That means p block elements means the differentiating electron enters into p orbital. First point, p orbital. This block contains 6 groups. These are 6 groups, 13, 14, 15, 16, 17, 18. And 13 group starts the electronic configuration ns2, np1, p2, p3, p4, p5, p6. Therefore, the electronic configuration, general electronic configuration of p block is ns2, np 1 to 6. In s block, all these elements are metals. But in case of p block, some metals, most of non-metals, and metalloids are also present. Inert gas elements are also present. Metalloid means the substance which possesses both metallic nature as well as non-metallic nature. Metal as well as non-metal, those are called metalloids. So p block lo metals untai, ekkuga non-metals untai, and then inert gas elements, halogens, ivanni deenlo untai. So p block configuration is ns2, np 1 to 6. Then coming to d block. D block elements. D block elements means the differentiating electron enters into d orbital. The differentiating electron enters into d orbital. D orbital. Idaithe s orbital, p orbital, d orbital. So the differentiating electron enters into d orbital. Those elements belong to d block. The d block placed in between s block and p block. D block ekkada untundi ante s ki p ki madhyalo untundi. So because d orbital contains 10 electrons. D orbital means 5 orbitals, 10 electrons. 5, 6, 7, 8, 9, 10. So because of presence of 10 electrons, D block contains 10 groups. 10 groups. So D block lo 10 groups untai. చూడండి ఇక్కడ నుంచి 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th. సో ఈ 10 గ్రూప్స్ని మనం D బ్లాక్ కింద చెప్తాం. సో ఇక్కడ ఫస్ట్ ఎలిమెంట్ తీసుకుంటే D బ్లాక్లో the D block starts with D1. That means with S block and P block, NS, NP completed. NS orbital, NP orbital, both are completed. That means the outer shell completed, the outermost shell. Valency shell, S and P are called valency shell. They are completed. Then the electron enters into inner shells. This is called penultimate shell. Penultimate shell means the shell before outermost shell. That means D. N, S, N, P. These are outer shells. Outer shell. Valency shell. N minus 1 D. This is called penultimate shell. Inner shell. Penultimate shell. And then N minus 2 F. It is called anti-penultimate shell. Anti-penultimate shell. That means innermost shell. So SP are completed with S block and P block. Then D block starts with N minus 1 D1. That means the differentiating electron enters into inner shell, that is D orbital, D shell. D starts, D1 starts with D block. The first element in D block is scandium. Scandium. Its atomic number is 21. So, it is scandium. Scandium, the first row of the D block scandium titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. So with this the D block completed. 10 elements, 10 groups. So the first scandium, it starts scandium argon 4s2 3d1. 3d1 starts, and then zinc 30, argon 4s2 3d10 30. That means scandium to zinc. Scandium to zinc. That means 3d1 starts and 3d10 ends. D block ends. The first row starts with 3d1 and 3d10 తో ఎండ్ అయిపోతుంది, 3d10తో ఎండ్ అవుతుంది. కాబట్టి దీన్ని 3d సిరీస్ అంటారు. సో D బ్లాక్లో 3d, 4d, 5d, 6d సిరీస్ అని ఉంటాయి. So 3d series means the elements starts with 3d1 ends with 3d10. Similarly కిందకు వస్తే yttrium, Y is called yttrium. 4d1 starts and cadmium తో ఎండ్ అవుతుంది. అలాగే చివరిలో mercury, and this is incomplete period. So every first element starts with D1, 3d1, 3d10, 4d1, 4d10, 5d1 to 5d10, 6d1 to incomplete. So like that there are 3d, 4d, 5d, 6d series. These are present in D block. 3d, 4d, 5d series, these are completely filled, and 6d is incomplete. These are completely filled. So these called D block elements. So D block means the differentiating electron enters into n-1d orbital. It contains 10 groups, third group to 12th group. It contains 4 series, 3d, 4d, 5d series, which are completely filled, and 6d series incomplete. Then what is the electronic configuration? General electronic configuration of D block means ns2 n-1d 1 to 10. This ns 1 to 2. This is the electronic configuration of D block. That means the elements arranged or entered into D orbital, D1 to D10, then D block completed. And the elements in this D block are called transition elements. These are all hard metals. They possess melting and high melting and boiling points. These are all hard metals. Then coming to F block. F block. F block means it is placed at the bottom of the periodic table. F block means the differentiating electron enters into F orbital. F orbital means it is anti-penultimate shell, innermost shell. So this is called F block. It is placed at the bottom of the periodic table because F orbital contains 14 electrons. 7 orbitals, 14 electrons. So that's why it contains 14 groups. So ikkadi nunchi ikkadiki 14 groups untai. This is called cerium, atomic number 58 to 71, lutetium. Thorium to lawrencium, 14 elements. In these elements, from cerium to lutetium, the electron enters into F orbital, that is F starts 4f1 to 4f14. That means F orbital completely filled. That's why it is called 4f series, 4f శ్రేణి అని పిలుస్తారు. అలాగే this is it starts with 5f1, ends with 5f14. This is called 5f series. Just like in D block 3d, 4d, 5d series ఎలా అయితే ఉన్నాయో F block లో వచ్చేసరికి 4F సిరీస్ 5F సిరీస్ అని పిలుస్తాము. 4F సిరీస్ 4F 1తో స్టార్ట్ అయ్యి 4F 14తో ఎండ్ అవుతుంది. 5F సిరీస్ మీన్స్ 5F 1తో స్టార్ట్ అయ్యి 14తో ఎండ్ అవుతుంది. అండ్ మనం ఇందాక చెప్పుకున్నాం దీస్ ఎలిమెంట్స్ 58 to 71, the actual place of these elements is in third group, that is after lanthanum. So that's why these are called lanthanides, and similarly 5F series called actinides. So in F block there are two series, 4F and 5F series. So 4F is called lanthanides because they are placed after lanthanum. They follow lanthanum. So that's why they are called lanthanides. And 5F series called actinides. 5F series called actinides. These two series, 4F and 5F, combinedly together called inner transition elements. Inner transition elements. D block elements are called transition elements, and F block elements are called inner transition elements. This is the classification of elements into 4 blocks. This is based on the entering of the differentiating electron enters into various orbitals like s orbital, p orbital, d orbital and f orbitals. So these are 4 blocks: s block, p block, d block and f block. And then coming to the next classification based on the properties. So based on the properties also the elements are classified into 4 types. These are 4 blocks. These are based on the electronic configuration, that means differentiating electron ఎందులో అయితే వెళ్తుందో దాన్ని బట్టి 4 బ్లాక్స్గా డివైడ్ చేసాం. దెన్ వాట్ ఆర్ ద ప్రాపర్టీస్ ఆఫ్ దీస్ ఎలిమెంట్స్ విచ్ ఆర్ ప్రజెంట్ ఇన్ ద బ్లాక్స్ అంటే వీటి యొక్క ధర్మాలని ఆధారంగా చేసుకుని ఈ బ్లాక్లో ఉండే ఎలిమెంట్స్ యొక్క ప్రాపర్టీస్ ఎలా ఉంటాయి అనే దాన్ని బట్టి మనం మళ్ళీ ఈ మూలకాలని 4 టైప్స్లో డివైడ్ చేసాం. సో వాట్ ఆర్ దోస్ 4 టైప్స్? లెట్ us see. Types of elements. Types of elements. So this is based on properties. Based on properties of elements. Based on the properties of elements, the elements are divided into 4 types. This first one is inert gas elements. Inert gas elements. Yes, we already studied inert gas elements means helium, neon, argon, krypton, xenon and radon. Helium, neon, argon, krypton, xenon, radon. These are placed in P block. So inert gas elements ekkada untayi ante P block lo untayi at the end of the periodic table. And these are special elements because if you consider the electronic configuration, except helium, the remaining all elements possess the general configuration ns2np6. Helium contains 1s2 configuration, and the neon, argon, krypton, xenon, radon, they possess ns2np6 configuration. That means s orbital completely filled, p orbital completely filled. That means they possess 8 electrons in the valency. This is called octet configuration. Octet configuration. అష్టక నియమము అంటారు. అష్టక విన్యాసాన్ని కలిగి ఉంటాయి. సో ఏ ఎలిమెంట్ అయినా ఈ ns2np6 ఆక్టెట్ కాన్ఫిగరేషన్ని కలిగి ఉంటే దట్ ఈజ్ మోర్ స్టేబుల్, దానికి స్థిరత్వం ఎక్కువ అని చెప్తాం. సో కాబట్టి పీరియాడిక్ టేబుల్లో the most stable elements means inert gas elements. See, this helium is actually misplaced in p block because the differentiating electron enters into s orbital. The actual place of this helium is in s block. చూడండి, ద చివరి ఎలక్ట్రాన్ ఎస్ ఆర్బిటల్లోకి వెళ్తే ఆ ఎలిమెంట్ ఎస్ బ్లాక్కి చెందింది అంటాం. అంటే హీలియం యాక్చువల్గా ఎస్ బ్లాక్లో ఉండాలి, కానీ ప్రాపర్టీస్ని బేస్ చేసుకుంటే ఆక్టెట్ కాన్ఫిగరేషన్ ఉన్న ఈ ఎలిమెంట్స్కి ఏ ప్రాపర్టీస్ అయితే ఉంటాయో ఆ ధర్మాల్ని హీలియం ఎగ్జిబిట్ చేస్తుంది కాబట్టి ఇట్ ఈస్ ప్లేస్డ్ ఇన్ పీ బ్లాక్. సో దట్ మీన్స్ ఇట్ ఈస్ మిస్ప్లేస్డ్ ఇన్ పీ బ్లాక్ అని చెప్తాం. సో దట్ మీన్స్ హీలియం ఈజ్ ఆల్సో స్టేబుల్ ఎలిమెంట్, స్థిరత్వాన్ని కలిగినటువంటి మూలకం. సో ఈ ఇనర్ట్ గ్యాస్ ఎలిమెంట్స్ అన్నీ కూడా ఎస్పీ ఆర్బిటల్స్, అవుటర్ మోస్ట్ ఆర్బిటల్స్ కంప్లీట్లీ ఫిల్డ్ ఉండటం వల్ల దే డు నాట్ పార్టిసిపేట్ ఇన్ ఎనీ కెమికల్ యాక్టివిటీ. కెమికల్ రియాక్షన్లో ఎలాంటి యాక్టివిటీని కనబరచవు, అంటే వీటికి చర్యాశీలత అనేది ఉండదు. దే డు నాట్ పార్టిసిపేట్ ఇన్ ఎనీ కెమికల్ రియాక్షన్ because they already attained the stability. So there is no need to lose electron or gain electron or share electron to get the stability. So that's why they are called inert elements, and all these are gaseous elements. So that's why they are called inert gas elements. But the heavier elements like krypton and xenon, it is a heavier elements. That means the atomic mass is more. So due to this large atomic size and low ionization enthalpy, low energy, at some conditions only this xenon participate in chemical reaction. It reacts with the most electronegative elements like fluorine and oxygen. In rare cases, this xenon reacts with fluorine and oxygen, the most electronegative elements, and form fluorides and oxides. So that's why instead of calling inert gas elements, they are also called noble gas elements, noble gases. సో యాక్చువల్గా ఆక్టెట్ కాన్ఫిగరేషన్ ఉండటం వల్ల ఎస్ అండ్ పి ఆర్బిటల్స్ కంప్లీట్లీ ఫిల్డ్ ఉండటం వల్ల ఇవి చర్యలో పాల్గొనవు. కానీ అటామిక్ మాస్ ఎక్కువగా ఉండటం వల్ల జినాన్ అనేది కొన్ని కండిషన్స్ దగ్గర మాత్రమే ఎక్కువ ఎలక్ట్రోనెగటివిటీ, రుణ విద్యుదాత్మకత ఉన్న ఆక్సిజన్ ఫ్లోరిన్తో చర్య జరిపి ఆక్సైడ్లను ఫ్లోరైడ్లను ఏర్పరుస్తుంది. అందుకని వీటిని ఇనర్ట్ గ్యాస్ ఎలిమెంట్స్ అనడానికి బదులుగా నోబుల్ గ్యాసెస్ అని కూడా పిలుస్తారు. సో దీస్ ఆర్ కాల్డ్ నోబుల్ గ్యాసెస్. సో హియర్ ఆల్ దీస్ ఎలిమెంట్స్ ఆర్ కాల్డ్ ఇనర్ట్ గ్యాస్ ఎలిమెంట్స్. దే do not participate in chemical reaction due to octet configuration. So this is the first type of elements called inert gas elements. And the second one is representative elements. Representative elements or normal elements. Representative or normal elements means all S block and P block except inert gases. All S block and P block elements except inert gases. Ante first group, second group, third, fourth, 13, 14, 15, 16, 17. చూడండి ఇవి. సో ఫస్ట్ గ్రూప్ అంటే ఇవి ఆల్కలీ మెటల్స్, ఆల్కలైన్ ఎర్త్ మెటల్స్, ఎస్ బ్లాక్ ఎలిమెంట్స్. అండ్ దెన్ పీ బ్లాక్లోకి వచ్చేసరికి 13, 14, 15, 16, 17 హాలోజన్స్ దాకా. సో వీటిని రిప్రజెంటేటివ్ ఎలిమెంట్స్ లేదా నార్మల్ ఎలిమెంట్స్ అంటారు. ఇక్కడ ఇనర్ట్ గ్యాస్ ఎలిమెంట్స్కి కాన్ఫిగరేషన్ NS2 NP6 ఎక్సెప్ట్ హీలియం it is NS2 configuration. That is called octet configuration. Then what is the configuration of representative element? What is the meaning of definition of representative elements? Means the elements in which the outermost shell N and NS and NP, the outermost shell is incomplete. Outermost shell is incomplete. So NSNP outermost shell incomplete గా ఉంటే దాన్ని మన representative element అంటారు. సో ఇక్కడ NS2 NP5 NS1 నుండి NS2 NP5, these are called representative elements. And all these representative elements, if you consider the first group, second group, they are strong metals. They possess basic nature. First group and second group. First group, second group. These are all metals. They act as reducing agents. Reducing agents. They exhibit the oxidation state +1, +2. The first group elements exhibit oxidation state +1 and the second group exhibits +2 because they all possess one configuration in the outermost and these elements possess two configuration. These are all metals. That's why they have the tendency to lose that one electron, and these elements have the tendency to lose two electrons to get the stability. So they exhibit +1, +2 oxidation states. And similarly here we consider the p block elements 13, 14, 15, 16, 17 elements. 17th group elements are called halogens. These are called halogens. They have the configuration NS2 NP5. That means they have the tendency to gain one electron to get the stability. Fluorine, chlorine, bromine, iodine, astatine. It is the radioactive element, and these are configuration NS2 NP5. Means 7 electrons in the valency. To get the stability, they have the tendency to gain one electron. So that's why these are all exist as minus, F minus, Cl minus, Br minus. And these first A group elements, lithium, sodium, potassium, rubidium, cesium, francium. It is a radioactive element. Except lithium, this also exists plus oxidation state, but this is due to small size. It forms covalent compounds. See, lithium and beryllium, due to small size, they form covalent bonds, and the remaining all these elements, they form ionic bonds with these halogens, ionic compounds. Ionic compounds. That means the first A group elements and second group elements, they are strong metals. First A group elements, alkali metals, are more strong when compared with the second A group. That means they have more tendency to lose one electron. Similarly, halogens means they have more tendency to gain one electron. That's why when first group and seventh group elements combined together, they form strong ionic compounds. So these are form ionic compounds. Except lithium and beryllium, beryllium, these two elements form covalent compounds due to small size and high ionization enthalpy. So this is representative elements, means all S block and P block elements except inert gas elements are called representative or normal elements. Then these first group and seventh group, they are more electropositive, and these more electronegative elements. These are called representative elements. in which the outermost shell is incomplete. Next, coming to transition elements. Transition elements. Transition elements means they are placed in D block. That means these are placed in between S block and P block. See, S block ki P block ki ఉండేటువంటి ప్రాపర్టీస్కి మధ్యస్థంగా ఈ ఎలిమెంట్స్ యొక్క ప్రాపర్టీస్ ఉంటాయి. అందుకే వీటిని ట్రాన్సిషన్ ఎలిమెంట్స్ అంటారు, పరివర్తన మూలకాలు. సో డి బ్లాక్లో ఉండే ఎలిమెంట్స్ని ట్రాన్సిషన్ ఎలిమెంట్స్ అంటారు. అయితే అన్ని డి బ్లాక్ ఎలిమెంట్స్ ట్రాన్సిషన్ ఎలిమెంట్స్ కాదు. See, what is the definition of transition elements means in which the outer shell and penultimate shell both are incomplete. చూడండి, inert gas elements means all are completely filled. Octet configuration. Representative elements means outer shell incomplete. So the elements in which outermost shell is incomplete called representative elements, and transition elements means the elements in which the outermost and the penultimate shell both are incomplete. Those elements are called transition elements. See, if you consider the transition elements, D block elements, D block third, fourth, fifth, sixth, 7th, 8, 9, 10, 11, 12. These are 10 groups that are belongs to D block. The elements present in these are called transition elements, but in case of 12th group, zinc, cadmium, mercury. If you consider the electronic configuration, we already discussed there are 4 series. This is called 3D series, 4D, 5D, 6D series. 3D series means zinc has configuration 3D10, cadmium 4D10, 5D10. That means D orbital is completely filled, 10 electrons. The maximum electrons present in D means 10. The D10, 4D10, 5D10 means the D electrons are completely filled in case of zinc, cadmium, mercury. But the definition is the n-1d orbital incomplete. Those elements are called transition elements. So that's why zinc, cadmium, mercury are not true transition elements. True transition elements. Then why they placed in D block means the differentiating electron enters into D orbital. That's why they are placed in D block. So zinc, cadmium, mercury are D block elements, but they are not transition elements. Here mercury is a liquid metal. See, but it is not a transition element. Actually, all these elements in D block are hard metals. But mercury is a liquid metal. It exists as a liquid at room temperature. So these are called transition elements. Transition elements means they are placed in between S block and P block. The elements in which the outermost shell and the penultimate shell both are incomplete. And here zinc, cadmium, mercury, they are not true transition elements because their penultimate shell D orbital that is completely filled. So that's why these are not true transition elements, but they are D block elements. And also coming to the properties of these elements, they show some special properties when compared with the S block and P block elements. S block and P block elements తో కంపేర్ చేస్తే ట్రాన్సిషన్ ఎలిమెంట్స్కి కొన్ని స్పెషల్ ప్రాపర్టీస్ ఉంటాయి, ఎగ్జిబిట్ చేస్తాయి. Because of the vacancy in n-1d orbital ఎందుకు ఆ స్పెషల్ ప్రాపర్టీస్ని అవి ఎగ్జిబిట్ చేస్తాయి అంటే, ఇన్ ఆల్ దీస్ ఎలిమెంట్స్ ద ఎలక్ట్రాన్ ఎంటర్స్ ఇంటూ n-1d ఆర్బిటాల్. సో డ్యూ టు ద వేకెన్సీ ఇన్ n-1d subshell, if you consider scandium 3d1 means only one electron is present. The remaining orbitals are all vacant. 3d orbital, this is only one electron. The remaining are all vacant. అంటే ఇంకా ఇందులోకి ఎలక్ట్రాన్స్ వెళ్ళే ఛాన్స్ ఉంది. సో ఇలా ఇన్కంప్లీట్ d ఆర్బిటాల్స్, వేకెన్సీ ఇన్ n-1d ఆర్బిటాల్ ఉండటం వల్ల they show some special properties when compared with S block and P block. What are those special properties means? First one, they exhibit variable oxidation states. Variable oxidation states. One element exhibit different oxidation states. For example, if you consider S block elements, the first A group element only one oxidation state, that is +1. The second group element means +2, like that. But in case of d orbital, if you consider iron Fe, it exhibits +2 and Fe +3 oxidation state. The same iron, it exhibits +2 and 3 different oxidation states. Variable oxidation states. అలాగే ఇప్పుడు manganese, it exhibits most of oxidation states up to 6. The group number is the maximum oxidation states. Group number, that means it also exhibits 7 oxidation states. Say the manganese here, Mn+7 oxidation state. Copper, Cu+2. But zinc, cadmium, mercury, they exhibit only one oxidation state. Zinc means +2. That is the only oxidation states. So the elements, transition elements, exhibit more than one oxidation state. That is the special property of these elements. They form colored ions. They form colored ions. So due to this same reason, they also exhibit colored compounds. If you consider copper in aqueous state, it is blue in color. Manganese, pink in color. Like that, they form colored ions. They act as catalyst. Catalytic activity ni kaligi untai. For example, nickel, it is used as a catalyst in the manufacture of oils, dalda. హైడ్రోజనేషన్ ఆఫ్ ఆయిల్స్లో నికెల్ని క్యాటలిస్ట్గా యూజ్ చేస్తాం. హేబర్ట్స్ ప్రాసెస్, ఐరన్ ఈజ్ యూజ్డ్ యాజ్ క్యాటలిస్ట్, లైక్ దట్. వెనడియం, ఇట్ ఈస్ ఆల్సో యూజ్డ్ V2O5 యాజ్ క్యాటలిస్ట్ ఇన్ కాంటాక్ట్ ప్రాసెస్, లైక్ దట్. దే యాక్ట్ యాజ్ catalyst. They form complex ions. They form complex compounds. So due to the vacancy of n-1d orbital, they form complex compounds. They show magnetic nature. They show magnetic nature, magnetic behavior, paramagnetic, diamagnetic. They exhibit paramagnetic, diamagnetic, like that. They have magnetic property. That means this property consists of, it depends upon the number of unpaired electrons. If any element, it contains unpaired electrons, it is a paramagnetic in nature. If it is completely filled orbitals, it is a diamagnetic in nature. Like that, it shows, they show magnetic nature. So these are all the important special properties of S block transition elements. That means these are in between S block and P block. ఈ రెండు బ్లాక్స్ ఎగ్జిబిట్ చేయనటువంటి ప్రాపర్టీస్ని ఇవి ఎగ్జిబిట్ చేస్తాయి. దీస్ ఆర్ కాల్డ్ ట్రాన్సిషన్ ఎలిమెంట్స్. అండ్ దెన్ ఇన్నర్ ట్రాన్సిషన్ ఎలిమెంట్స్. inner transition elements. Inner transition elements means F block elements. They are called inner transition elements. They are placed at the bottom of the periodic table. These are called lanthanides and actinides. Lanthanides means 4F series and 5F series. Yes, what is the definition of inner transition elements? Means the elements in which the outer shell, penultimate shell and anti-penultimate shell both are incomplete. So outer shell, penultimate shell, anti-penultimate shell, all these shells are incomplete. Then these elements are called inner transition elements. F block elements are called inner transition elements. They are 4F series and 5F series. They are considered as lanthanides and actinides. So this is the types of elements based on the properties of elements. So like that, the classification of elements means long form of periodic table based on the atomic number, Moseley's periodic law, and based on the differentiating electron entering, they are classified into S block, P block, D block and F block. And based on the properties of the elements, there are 4 types. These are inert gas elements, representative elements, transition elements and inner transition elements. This is the classification of elements. In the next class, we are going to discuss about periodicity in properties.